What is a levorotatory?
Having the property of rotating plane polarized light counterclockwise.
Is ceviche really cooked by lime juice?
The results of cooking with heat and with acid are similar, but of course they are not exactly the same. Both heat and acid serve to denature proteins in food, which is a technical way of saying that the molecules change shape. With access to any number of shapes that it couldn't exist in beforehand. The molecule finds new ways to react both with itself and with other protein molecules. These recently liberated proteins quickly form a solid network, which is why fish gets firmer and whiter when you add lime juice. And it's the same reason that egg whites turn opaque and get harder upon cooking.
What is a lipid?
Lipids are a broad class of nonpolar or amphiphilic molecules including fatty acids, vitamins, sterols, and waxes, among others. An amphiphilic molecule is one that has both hydrophilic and hydrophobic groups, meaning that some parts of the molecule interact favorably with polar groups while other parts do not.
How can light be used to initiate a chemical reaction?
When light strikes a molecule, it has the potential to excite an electron to a higher energy level. When this happens, the molecule becomes less stable and more reactive. This can even cause the molecule to fragment, generating a more reactive species or catalyst, which can then go on to react with another molecule.
What is a racemic?
A mixture of equal amounts of the two enantiomers of a chiral molecule.
How do modern chemists characterize the products of chemical reactions?
Chemists need to characterize the products of their chemical reactions so that they can be sure of the structure and composition of the molecule they have made. One common way is by measuring the melting point of a solid substance. This doesn't provide specific information about the arrangement of chemical bonds in a molecule, though, so more advanced techniques are required to completely characterize a molecule. These techniques often involve using electromagnetic radiation to probe the energy levels in the molecules. See Physical and Theoretical Chemistry for more on these topics. Knowledge of what energies/wavelengths of light the molecule can absorb can be related directly to structural features of the molecule.
How many nuclear power reactors are there in the world, and how many are currently under construction?
There are currently 436 nuclear power reactors around the world. The breakdown of the distribution by country is shown in the table below. Aside from the United States, a few other countries with large numbers of nuclear reactors are France, Russia, China, Japan, and Korea. Each of these nations has at least 20 nuclear reactors currently in operation.
What is an electron affinity?
The energy change upon adding an electron to a neutral species.
What is radioactive?
Emission of radiation or particles.
Why are scientists so interested in semiconductors?
Recall that semiconductors are a class of materials defined by their conductivity properties. Specifically, they have intermediate conductivity properties between those of things that conduct extremely well, like metals, and things that don't tend to conduct well at all, insulators. This is what makes them so useful. Scientists are able to use semiconductors to control the flow of electricity in circuits, which has been crucial for the development of all of the complicated electronic devices you're familiar with. Semiconductors can be doped with materials containing extra electrons, or with materials that are electron deficient, to control the direction of electron flow through the material. Semiconductors have also played a big role in developing solar energy capture devices. The amount of energy a semiconductor needs to absorb to release an electron such that electricity can flow can be finely tuned, allowing scientists to develop materials capable of storing solar energy from photons of light, in the form of electricity.
How do you measure molecular weight of a polymer?
The most common way is based on size. The technique is known as size exclusion chromatography, or gel permeation chromatography. The sample is passed through a column that has a porous solid material. The smaller polymers can work their way into those pores, while larger molecules don't interact with the solid material. The biggest molecules, because they don't interact with the solid phase, come out of the column first, followed by smaller and smaller molecules. The time it takes for a polymer to get through the porous column is related to its molecular weight. Okay, technically it's based on the hydrodynamic volume, but let's let this approximation slide. In practice, These instruments are calibrated using standard polymer samples of a known molecular weight.
Why did William Francis Gioke, United States, win the Nobel Prize for Chemistry?
For his contributions in the field of chemical thermodynamics, particularly concerning the behavior of substances at extremely low temperatures. Gioke's work did much to prove the third law of thermodynamics, originally proposed by Nernst, and helped make it possible to calculate the free energies of formation of molecules. Much of this was made possible by experiments performed at extremely low temperatures. And Gioke can be credited for developing the methods necessary to perform these experiments at temperatures close to absolute zero. Gioke's work explored the entropy, or disorder, associated with various forms of various substances. And he did much of the pioneering work in studying molecules at low temperatures.
What is a bonding orbital?
A molecular orbital that is more stable than the atomic orbitals that were combined to generate it.
What does infrared, IR, spectroscopy measure, and what does it tell you about a compound?
Infrared spectroscopy measures the absorption of light by molecules in the infrared region of the spectrum, which provides information on the types of functional groups present in a molecule. For example, looking at the infrared spectrum can provide evidence as to whether certain pairs of atoms are bonded by 1, 2, or 3 pairs of electrons. The shapes of the peaks in an infrared spectrum can also be used to gain information about intermolecular interactions between the species we are looking at and the surrounding medium.
What is a calorie?
A calorie is a unit of heat energy defined as the amount of energy it takes to raise 1 gram of water by 1 degree Celsius. Calories are also often used to describe the energy content of foods. When used for foods, a calorie actually refers to 1,000 calories, or a kilocalorie of energy, which can be rather confusing.
Is it true fresh eggs will sink in water, while bad ones will float? Why?
Yes. As an egg goes bad, proteins and other chemicals decompose and release volatile molecules like carbon dioxide, CO2. The shell of an egg is somewhat porous, so these gases can escape, decreasing the mass of the egg. Since the size of the egg doesn't change, assuming you don't break it, The density decreases as the egg ages, and it eventually becomes less dense than water. Whether it becomes buoyant exactly when it is spoiled or weeks after, we can't say. That's why your nose is so good at smelling that awful smell so that you don't eat rotten eggs.
Who first realized that air has weight?
It was actually a mathematician named Evangelista Torricelli who is the first on record to demonstrate that air has weight. His experiment to prove this fact was prompted by the observation that water from a mineshaft could only be pumped upward to reach a certain height. Torricelli thought that the air pushing down on the surface of the water must play a role. To test this theory, in 1643 he placed a sealed tube of mercury upside down in a bowl of mercury. He observed that the weight of the air would keep the mercury in the tube at a certain level. And on different days he observed that the mercury would rise to different levels. We now know this is because the air pressure varies from day to day. And Torricelli's experiment was the first barometer.
What is heat?
Transfer of energy between substances with different temperatures.
What is mass?
The resistance of an object to acceleration, commonly used interchangeably with weight. Though the latter depends on gravity while the former does not.
How much space does an atom occupy?
The atomic radius of the smallest atom, hydrogen, is 53 × 10 to 12 meters, so it is about 10 to 10 meters in size. The atomic radius of the largest atom, cesium, is about 270 × 10 to 12 meters, or roughly 5 times that of hydrogen. These are all very, very small sizes.
What is a physical change?
A physical change is a change involving the macroscopic properties of a substance without any accompanying change in chemical composition. A few examples of physical changes would be evaporating, melting, cutting, slicing, breaking, and grinding. The key similarity is that none of these processes involve changing the chemical makeup of the substance.
What is the collision theory?
Defines reaction rates as a function of the collision frequency.
What is normality?
Concentration of a solution defined as the molar concentration divided by an equivalence factor. I.e., H2SO4 can neutralize two equivalents of base with its two H end groups. So a 1m solution of H2SO4 is 2n, the equivalence factor of H2SO4 is 0.5.
Why do polar bears have black skin and clear fur?
There is some debate on the subject, but the combination of black skin and clear fur is probably the best for keeping the polar bear warm while not giving away its position when hunting. The black color of the skin is the best for absorbing energy from the sun. Objects that appear black don't reflect any wavelengths of light. The clear fur allows that light to get to the skin, but still looks white, so the bear can blend in with the surrounding ice and snow. A few years ago, or maybe you heard this recently because it has achieved urban legend status. A rumor you may have heard is that polar bear fur is actually like a fiber optic network for harnessing or focusing sunlight toward the bear's skin. While this would have been cool, it's unfortunately completely bogus.
What is biochemistry?
Biochemistry is the field focused on elucidating and explaining the complex chemical processes that take place in biological systems. It's a diverse field, drawing on aspects from virtually every other subfield of chemistry to explain the molecular processes that drive living things. Often, biochemists study complex reaction sequences and catalytic processes involving molecules much larger than those routinely encountered in other subfields of chemistry. A few topics commonly encountered in biochemistry include studying how our cells obtain energy, understanding how our genetic material, DNA, dictates who we are, and explaining how our body regulates and stores nutrients from the foods we eat.
What does it mean when we say a chemical reaction takes 1 minute?
When we say a reaction takes 1 minute, what we're really saying is that a certain fraction, specifically that fraction is 1-1/e, or about 63%, of the reactant molecules have gone on to form products after 1 minute has passed. E refers to the irrational number E equals 2.71828818. If we say a reaction takes 1 year, or any other amount of time, we're also referring to that same fraction of reactants becoming products. It's not that 100% of the reactants have become products, but rather just a certain fraction.
What is an independent variable?
A variable that is set to a specific, known value in an experiment.
Why did Yves Chauvin, France, Robert H. Grubbs, United States, and Richard R. Schrock, United States, win the Nobel Prize for Chemistry?
For the development of the metathesis method in organic synthesis. Chauvin, Grubbs, and Schrock shared the prize for their work on a metal-catalyzed reaction that exchanges, metathesizes, carbon-carbon double bonds. Many of the double bonds that react with these catalysts are very strong. So a reaction that breaks both bonds of a double bond is impressive indeed. Chauvin was the first to propose a detailed mechanism for this catalyzed reaction. Grubbs and Schrock independently developed extremely active catalysts for this reaction using primarily molybdenum and ruthenium metal centers, respectively.
What is a gel?
Gels are solid materials that have flexible properties, but do not actually flow in the same way that liquids do. They are made from a cross-linked bonding network of atoms, which actually contains a majority of liquid-like molecules interspersed by weight, but it still behaves as a solid. The cross-linked network within the gel gives it its solid-like properties, while the fluid component gives the gel its stickiness.
What is radical?
A species containing unpaired electron density, typically involving an odd number of valence electrons.
Why did Yves Chauvin, France, Robert H. Grubbs, United States, and Richard R. Schrock, United States, win the Nobel Prize for Chemistry?
For the development of the metathesis method in organic synthesis. Chauvin, Grubbs, and Schrock shared the prize for their work on a metal-catalyzed reaction that exchanges, metathesizes, carbon-carbon double bonds. Many of the double bonds that react with these catalysts are very strong. So a reaction that breaks both bonds of a double bond is impressive indeed. Chauvin was the first to propose a detailed mechanism for this catalyzed reaction. Grubbs and Schrock independently developed extremely active catalysts for this reaction using primarily molybdenum and ruthenium metal centers, respectively.
What is vulcanization?
Chemical reaction that creates cross-links between individual polymer chains in rubber.
Why is arsenic so poisonous?
Arsenic interrupts some of your body's most basic and common biochemical pathways. Arsenic, particularly as3+ and as5+ oxides, interferes with the citric acid cycle and respiration. Specifically reduction of NAD and ATP synthesis biochemistry. If that weren't enough to kill you, and it probably is. Arsenic also boosts the level of hydrogen peroxide in your body, which causes another whole set of problems. Unfortunately, these toxic forms of arsenic are not only water-soluble but can be found in well water from natural sources and man-made contamination from mining.
Why does salt melt ice?
Adding salt to ice lowers the melting point of water. See freezing point depression in macroscopic properties. So when you pour salt on the ice on your driveway, the melting point of the salt-water mixture you made by adding the salt may be lowered sufficiently such that it is below the outside temperature, which means the solid ice will start to melt.
Why did Sir William Ramsay, United Kingdom, win the Nobel Prize for Chemistry?
For the discovery of the inert gaseous elements in air, and his determination of their place in the periodic system. Lord Rayleigh noted in a lecture that he measured a difference in the density of nitrogen made synthetically in the lab, and the same substance isolated from air. Ramsay followed up on this observation, quickly isolating argon for the first time. He went on to discover neon, krypton, and xenon.
How far away can one molecule feel another?
Molecules feel one another through the intermolecular forces they exert on one another. These typically span lengths that are a little longer than the length of chemical bonds, or something in the neighborhood of 5 × 10⁻10 meters.
What is a stereoisomer?
Molecules that differ only in the spatial arrangement of their atoms.
What is hygroscopic?
A substance that readily absorbs water from its surroundings.
Why did Venkatraman Ramakrishnan, United States, Thomas A. Stites, United States, and Ada Ionath, Israel, win the Nobel Prize for Chemistry?
For studies of the structure and function of the ribosome. Ramakrishnan, Stites, and Ionath are responsible for uncovering the structure and function of the ribosome at the atomic level, and it is for that work that they share this Nobel Prize. They used X-ray crystallography to individually map each atom that makes up the ribosome. It consists of hundreds of thousands of atoms. The ribosome plays a crucial role in each cell, as it is responsible for the synthesis of proteins. On the basis of their results, these researchers have also developed models showing how antibiotics bind to the ribosome.
What is aromaticity?
Aromaticity is a special kind of resonance delocalization, one we've actually already seen. Delocalization of electrons always makes molecules more stable, compared to imaginary molecules where the electrons cannot spread out. If this delocalization takes place in a flat ring of n carbons, and the number of electrons involved is 4n plus 2, i.e., 2, 6, 10, 14, etc., then the system is called aromatic.
What is microwave spectroscopy?
Microwave spectroscopy, as the name implies, is spectroscopy carried out using electromagnetic radiation in the microwave region of the spectrum, 0.3 to 300 GHz. The energies associated with microwaves are relatively low, and these energies are typically a good match for energy level spacing between the different rotational levels of molecules. Thus, microwave spectroscopy is typically used to study the rotational energy levels of molecules. The rotational energy levels of molecules are typically studied in the gas phase.
How can I make a miniature rocket from a film canister?
Chemistry principles encountered in this experiment: gases and pressure, chemical reactions, materials you'll need. An empty, plastic 35 mm film canister, which are getting more and more rare these days. If you cannot locate one of these, you could try using any other small, lightweight, plastic container with a lid that easily pops on or off. An Alka-Seltzer, R, or other antacid tablet water the procedure. This experiment should be performed outdoors in an open area. Add about 1 teaspoon of water to the film canister, and leave the lid open. Break the antacid tablet in half and get ready to add it to the container. This step requires you to be quick. Drop the broken antacid tablet into the container. Then quickly close the lid and place the canister on the ground with the cap side down. Stand back a good distance, and wait for the rocket to launch. The Alka-Seltzer, R, will react with the water in a reaction that produces carbon dioxide gas. The pressure of this gas will build and build until it exerts a force so great that it will blast the canister off of the cap, shooting the canister into the air. After about 10 to 15 seconds, the canister will launch into the air. Try repeating this experiment using different ratios of Alka-Seltzer, R, to water, or using canisters of different types or sizes. You might also compare different brands of antacid tablets, or different methods for crushing the tablet before you add it to the canister. Compete with your friends to see who can make the rocket that shoots the highest.
What is a salt bridge?
A method used to place the two sides, solutions, of an electrochemical cell in electrical contact.
How does cold medication work?
Unfortunately, doctors and scientists still have not found a cure for the common cold. Cold medicines work by trying to minimize the symptoms of a cold while your body is busy fighting the virus that caused it in the first place. Some medicines, like those you buy at your local drugstore, work by using antihistamines, pain medicines, and decongestants to help relieve symptoms. These include all of the things you typically associate with a cold: a runny nose, a scratchy throat, sneezing, and dry or itchy eyes. Other cold remedies try to help strengthen or support your body's immune system while it fights the cold. These include vitamins, often vitamin C, zinc supplements, and echinacea. You shouldn't expect these to bring immediate relief to your symptoms as you would with over-the-counter medications, though.
Can chemical reactions involve multiple steps?
Yes, and many do. While some chemical reactions may only involve a single step, others may involve 10 or more elementary steps. Of course, chemists working in different subfields may have different definitions of what constitutes a step of a reaction. Depending on what aspects of the reaction they focus on.
What is the pH?
A measure of the hydrogen ion concentration of a solution.
What is nuclear fusion?
Nuclear fusion is the process by which two nuclei combine to form a single, heavier nucleus. Energy is usually released when two lightweight nuclei fuse. Though for heavier nuclei, fusion generally requires an input of energy. Nuclear fusion can be used in bombs to cause a massive and rapid release of energy. Fusion is also responsible for the fact that stars burn bright and give off light and heat.
What is rigor mortis?
Rigor mortis is the stiffening of the muscles that occurs shortly after death. Since very little or no ATP is present, muscles are left contracted, stiff, and unable to relax.
So, to restate the question, why do plants reflect any light at all?
The easiest answer here is that absorbing red and blue energy obviously works well enough. So evolution stuck with it. Evolution, after all, doesn't provide the best solution, but rather a solution. Nonetheless, let's make some guesses as to why plants are green. Chlorophyll isn't just after energy in general, but needs very specific wavelengths to pass along energy to the reactive centers of photosystems I and II. The second reasonable guess is that too much energy is not a good thing. Absorption of light creates high-energy species. And if they aren't used in some productive way, the energy will find something else to do. These other reactions could be destructive to cells. In sum, chlorophyll only takes what it needs or what it can use.
How are metals important in maintaining osmotic balance in cells?
The metals sodium and potassium, really they're ions, Na and Nk+, are responsible for moderating ion and concentration gradients across cellular membranes. These ions can be selectively allowed to pass, or be pumped, across cellular membranes.
What is an anion?
An anion is a negatively charged atom or molecule. Anions have a larger number of electrons than protons, such that they have a net negative charge.
What is genetic engineering?
Genetic engineering is the process of changing the genetic makeup of cells or organisms to produce versions with specific traits or to produce new organisms altogether.
What is PS, polystyrene?
If one of the hydrogen atoms on every ethylene monomer in polyethylene is replaced by a benzene ring. Note again that this is not how this material is actually made. You get PS, or polystyrene. Polystyrene is usually the fourth largest volume polymer produced globally, with billions of pounds made annually. Polystyrene can be manufactured into parts, like CD cases, furniture, and eating utensils. Or air can be mixed with the polymer to make a foam used in insulation both for your house and your coffee cup. Styrofoam, R, is a trademark name held by the Dow Chemical Company for foamed polystyrene.
What is electrical resistivity?
Electrical resistivity is a measure of how well a material resists the flow of an electric current. A material with a high electrical resistivity is a poor conductor of electricity, while a material with a low electrical resistivity is a good conductor of electricity.
What is flame ionization detection?
Flame ionization detection, FID, is a method of detecting organic analytes in gas phase chromatography experiments. A very hot flame is used to burn the analytes emerging from the chromatography instrument, which produces positively charged ions. These ions are then attracted to a negatively charged electrode, which detects them by generating an amount of current proportional to the number of positively charged carbon atoms reaching the electrode. FID can be particularly useful due to the fact that it detects organic analytes without any interference from a wide variety of other gases, which can be present in the sample or in the carrier gas used in the gas chromatograph. There are some downsides to FID, one of which is that the sample is destroyed as it is analyzed.
What is an excited state?
An atom or molecule in any electronic state of higher energy than its lowest energy state.
How long are chemical bonds?
Chemical bonds are typically about 2 atomic radii in length. Since they are formed from 2 atoms joined together, these distances are on the order of 10 to 10 meters.
What determines which metals can be magnetized?
Chemists discuss magnetism in terms of 3 basic categories: diamagnetism, paramagnetism, and ferromagnetism. Diamagnetic materials have all of their electrons arranged in pairs, which, by definition, means that their spin magnetic moments must all be arranged in pairs and thus cancel each other out. For this reason, diamagnetic materials cannot be magnetic, and won't be influenced by magnetic fields. Paramagnetic materials have unpaired electrons, but in these materials the electrons spin magnetic. Moments cannot all be lined up in the same direction, which means that they cannot be strongly magnetic. Since they do have unpaired electrons, they can be influenced by applied magnetic fields, but not to the same extent as the third class, ferromagnetic materials. Ferromagnetic materials are the materials that can give rise to the magnets we're all familiar with. All of the materials that magnets can interact strongly with are ferromagnetic. In these materials, there are unpaired electrons whose magnetic spin can all be aligned in the same direction. Note that just because a material is ferromagnetic doesn't mean it must be a magnet, but rather just that it has the potential to be magnetized. Take a paper clip, for example. When you first pick it up, it's not a magnet. But you can turn it into a weak magnet by holding a magnet next to it for a short length of time. Some of the most common ferromagnetic substances are those made of iron, nickel, or cobalt.
What is a substituent?
A substituent is an atom, or group of atoms, attached to a specific position in a molecule. For example, in the molecule 3-bromopentane, see drawing below. We could refer to the bromine as a substituent on the third carbon atom.
What is a homogeneous mixture?
A sample containing only one pure substance.
Why is heating often used in chemical synthesis?
Heat is often used in chemical synthesis to increase the rate of a reaction. In some cases, heating is also used to effect a phase change. To minimize the environmental impact of a chemical synthesis, it is often optimal to seek reactions that proceed readily at ambient temperatures so that energy input in the form of heating is not necessary.
What molecular properties lead to higher boiling points?
There are a few factors that play important roles in boiling points of substances. The first is molecular weight. In general, heavier molecules have higher boiling points, which is pretty straightforward considering how we defined boiling point above. Heavier molecules take more energy to move from the liquid to the gas phase. All other properties that affect boiling point deal with intermolecular forces, or interactions between molecules. Think of this like the affinity of one molecule of a substance to be attracted to, or stick to, another molecule. Non-covalent bonds, like ionic or hydrogen bonds, significantly increase boiling point. Why? Because to move to the vapor phase, the molecules typically have to break these interactions. Dipole interactions and van der Waals forces have similar effects, see atoms and molecules. But these interactions are weaker, so the effect they have on boiling points is smaller. Finally, branching of the carbon backbone of a molecule is also frequently touted as a factor leading to lower boiling points. While this is true, it is really the weakening of van der Waals forces at work here too.
How can I make black snake fireworks from items around my house?
Note, this experiment involves fire and flammable materials, so adult supervision is required. Also, check your local laws before attempting this experiment. Chemistry principles encountered in this experiment. Chemical reactions, combustion reactions, materials you'll need: sand, about 2 cups, lighter fluid, a small bottle of about 100 milliliters. Baking soda, 1 tablespoon, sugar, 4 tablespoons. Cup or bowl: an outdoor location where you can light the black snake firework safely without damaging anything. The procedure: in a cup or bowl, mix 4 tablespoons of sugar with 1 tablespoon of baking soda. Use the sand to form a pile, in your chosen safe outdoor location. And then create a depression in the middle of the sand. This depression is where you will ignite the black snake firework. Pour a small amount of lighter fluid onto the sand to wet it. Try this experiment first with a very small amount of lighter fluid, and, if necessary, repeat the experiment with incrementally larger amounts. It's better to start too small than too big. Pour your mixture of sugar and baking soda into the wetted depression in the sand. You don't have to use it all at once. Feel free to experiment with different quantities of the baking soda and sugar mixture. Carefully ignite the lighter fluid with a match and stand back. You should see the mixture create long snakes of black ash. The burning sugar and baking soda form sodium carbonate, water vapor, and carbon dioxide gas. The ash in the snake is composed of carbonate and burnt carbon.
How do you measure conductivity of a solution?
Conductivity describes the ability of a solution to conduct an electric current. There are a few methods for measuring the conductivity of a solution, and the most straightforward to understand is probably the amperometric method. This method simply applies a voltage between 2 electrodes and measures the current. While this method is simple to describe, it can have complications in practice, and it isn't always the most accurate method. Another way of measuring conductivity is with a potentiometric method, which makes use of 2 pairs of rings. There are 2 outer rings that apply an alternating voltage, and this results in a loop of current being generated in the solution. The other pair of rings sits inside the first and measures the change in voltage between the pairs of rings. This change in voltage is directly related to the magnitude of the current loop induced by the outer rings, which is in turn directly related to the conductivity of the solution. Other methods exist to measure conductivity, but these are probably the easiest to both describe and understand.
What is an element?
Atoms with the same atomic number.
What is a catalyst?
Any substance that increases the rate of a chemical reaction without being consumed by the reaction.
Why is chemistry the central science?
Chemistry is called the central science because it's related to everything. It connects and draws from topics in biology, physics, materials science, mathematics, engineering, and other fields. Chemistry is important to how our body functions, to the food we eat, to how our medicines work, and to pretty much everything else in our lives. After reading this book, we hope you'll agree.
Why did Irving Langmuir, United States, win the Nobel Prize for Chemistry?
For his discoveries and investigations in surface chemistry. As a graduate student, Langmuir studied light bulbs, and then went on to improve vacuum pump designs. These two interests merged, in some respects, and Langmuir was able to invent the incandescent light bulb. These led to his interest in surface chemistry, after observing that a tungsten filament, like those in a light bulb, could split H2 on its surface, forming a single atomic layer of hydrogen atoms. The work of direct relevance to his receiving the prize, however, was his study of thin films of oil and surfactants on the surface of water. Langmuir postulated that the molecules of surfactants would orient themselves into a layer that was a single molecule thick. He went on to develop the physics to describe such thin layers, which would eventually be known as monolayers.
What determines whether a particular type of nucleus can be monitored by NMR spectroscopy?
Similar to electrons, nuclei can have a net spin, or spin-angular momentum. NMR spectroscopy can be used to study any nucleus that has a non-zero spin-angular momentum. Some common nuclei that chemists study by NMR are 1H, 2H, deuterium, 13C, 11B, 15N, 19F, and 31P.
Why did George A. Allah, United States/Hungary, win the Nobel Prize for Chemistry?
For his contribution to carbocation chemistry. Carbocations are species that contain one or more positively charged carbon atoms. While these Types of intermediates were postulated for years to play key roles in organic reactions. It was never believed that they could be isolated, due to the fact that they should be highly reactive. Allah managed to prepare stable carbocations through the use of extremely acidic compounds, which are actually called superacids. Allah's work thus revolutionized research into carbocation chemistry, as these species could finally be characterized for the first time. This work has been very influential in better understanding the role of these important intermediates in organic chemistry.
Why do baking soda and vinegar fizz so much when they react?
The chemical name for baking soda is sodium bicarbonate, and its chemical formula is NaHCO3. Vinegar consists mainly of acetic acid, CH3COOH, and water. When baking soda is added to vinegar, the following reaction takes place between the sodium bicarbonate and acetic acid. NaHCO3, AQ, plus CH3COOH, AQ, CO2, G, plus H2O, L, plus CH3COONA, AQ. It's the released CO2 that creates the bubbles and foaming appearance you see when the two are mixed.
What do the numbers on the periodic table mean?
The periodic table lists elements in boxes containing their name, atomic number, chemical symbol, and atomic mass, averaged over the natural abundances of the various isotopes.
What is a molarity?
A measure of concentration defined as moles of solute per liter of solvent.
What is chirality?
Chiral objects have non-superimposable mirror images.
What is hyperconjugation?
Hyperconjugation is another way to explain why substituted carbocations are more stable. The electrons in either the CC or CH bonds that are near the cationic center can interact with the empty p orbital. It's not the bonds that are directly connected, but rather one bond removed from the center carbon, that are the most important. See the illustration below. At the simplest level, this provides an explanation for the statement in the previous answer that neighboring carbon atoms are more electron donating than hydrogen atoms. It's really the neighboring CH bonds that help stabilize the empty p orbital.
Why did Johann Friedrich Wilhelm Adolf von Baeyer, Germany, win the Nobel Prize for Chemistry?
for the advancement of organic chemistry and the chemical industry. Through his work on organic dyes and hydroaromatic compounds, Bayer was the first to synthesize indigo, which is still a widely used dye. Although a different method is used to prepare it today.
How did ancient civilizations make bronze?
Tin had to be mined in the form of an ore and then purified through a process called smelting. Once the tin was pure, it could be added to molten copper. In whatever ratio was desired, to make bronze for use in things like tools and weapons.
What is the auto-ignition temperature of a substance?
The auto-ignition temperature is similar to the flash point, except that it does not require an ignition source to begin or to continue burning. Above the auto-ignition temperature, the vapor will start to burn and continue to burn, even in the absence of any ignition source.
What is a cathode?
Electrode where reduction occurs.
What is electrochemistry and how was it discovered?
Modern electrochemistry studies reactions that take place at the interface of an electronic conductor and a source of charged ions, possibly a liquid. The development of electrochemistry began with studies on magnetism, electric charge, and conductivity. The earliest experiments typically focused on questions surrounding properties of materials. For example, which materials can be magnetized and which materials can be charged. As early as the 1750s, scientists had discovered that electrical signals were important to human life and were using them to treat medical issues such as muscle spasms. In the late 1700s, Charles Coulomb developed laws describing the interactions of charged bodies, which are still used widely today and taught in any introductory course on electricity and magnetism. The first electrochemical cells were developed during the 1800s. Electrochemical cells are arrangements of electrodes and sources of ions that either generate electric current from a chemical reaction, or alternatively, use electricity to drive a chemical reaction. Today these cells find applications in daily life, such as in the batteries that power your car or cell phone. Today electrochemistry still constitutes an important field of research and is one that will likely continue to lead to the development of new products and technologies.
Who were Diels and Alder?
The Diels-Alder reaction, like many reactions in organic chemistry, is named after the chemists who discovered it, in this case Otto Paul Hermann Diels, 1876 to 1954, and Kurt Alder, 1902 to 1958. Kurt Alder was actually Diels' student at the University of Kiel, and Alder was awarded a PhD in 1926. Alder and his advisor Diels jointly received the Nobel Prize in Chemistry in 1950.
Are the north and south poles of the Earth magnetic poles?
Without getting too technical on the physics here, it gets way more complicated with the whole planet versus a tiny piece of iron on your fridge. Yes, the north and south poles are magnetic poles, but compasses point north. So what we call the North Pole is actually the South Magnetic Pole and vice versa.
Why did Alfred Werner, Switzerland, win the Nobel Prize for Chemistry?
For his work on the linkage of atoms in molecules, especially in inorganic chemistry. Werner was the first to propose the correct structure of inorganic compounds like Co, NH3, 4Cl2+. He proposed that the cobalt ion was in the center, surrounded by the ammonia and chloride ligands, in an octahedral arrangement. This proposal was consistent with the fact that two isomers of this compound were observed. As the two chloride ligands can be arranged either 180 degrees, trans, or 90 degrees, cis, apart from each other.
If polar bears have black skin and clear fur, why do they look white?
Polar bears appear white for the same reason that a pile of snow looks white: reflection. If there are a lot of surfaces that reflect light, either in the polar bear's fur or a snowdrift, then any light that hits the object will be bounced around many times before coming back toward your eye. Most wavelengths of light are scattered equally well, so you end up with the object looking white. In other words, no wavelengths are absorbed, which would give rise to a color.
What is an isotope?
Isotopes are atoms with the same number of protons and electrons, but with different numbers of neutrons. Since the numbers of protons and electrons effectively determine the reactivity of an atom, isotopes have the same basic chemical properties and are the same element. They have different masses, though, since they have different numbers of neutrons. The various isotopes of an element are usually present in relatively fixed ratios throughout nature. But in some cases the ratio can depend on the environment or molecule in which they are found. For example, the element carbon most commonly exists with 6 protons, 6 neutrons, and 6 electrons, referred to as carbon-12, the total number of particles in the nucleus. A small fraction, however, have 6 protons, 7 neutrons, and 6 electrons, carbon 13. Roughly 99% of carbon atoms have 6 neutrons, but most of the remaining 1% have 7 neutrons.
What is an isobaric process?
An isobaric process is a process that is carried out at a constant pressure.
Why did Sidney Altman, Canada, United States, and Thomas Seck, United States, win the Nobel Prize for Chemistry?
For their discovery of catalytic properties of RNA. While RNA was already known for its role as a molecule involved in heredity and the transport of genetic information, Altman and Seck discovered that RNA can also serve biocatalytic functions. This was a completely surprising result to the scientific community. The discovery was made when RNA was put into a test tube in the absence of any protein enzymes. And the RNA began to cut itself into pieces and rejoin the pieces back together again. This observation led to the discovery of the first RNA enzymes. By the time the prize was awarded, nearly 100 RNA enzymes had already been discovered.